Good morning. So today we're going to do a few sketches of polar graphs. Now, the technique I use for this, we're going to first sketch r equals 2 minus 2 cosine of theta. A way that works really well is if you sketch the wave doing amplitude, period, phase shift, all of those things that you would have learned earlier in the year. So with 2 minus 2 cosine of theta, the amplitude is 2. This number here is a vertical shift of 2, and it's just cosine of theta, so the period would equal 2 pi, and there isn't any horizontal shift. So if we do a sketch of what that wave would look like, amplitude, let's say vertical shift of 2, let's show that first. So 2 up, that's the new sinusoidal axis, like what the x-axis used to be. Amplitude of 2 means it's going to go up to 4 and down to 0. And the period is 2 pi. So 2 pi over there gets chopped up into 4 equal parts, like this. And then if you notice, it was a negative, so that means it's a reflection of the cosine curve, which tells us that it's going to be starting at the lowest point and then going up. And here's the points that I'm plotting. And then the cosine just goes like this. It's going upside down because it was a negative cosine. And then it will just start to repeat itself. So this is going to help us to graph the polar graph. So now what I do first is plot the important points, the easiest ones. I'll highlight them here. This point, that. We'll plot those points first over onto the polar paper. So at 0 degrees or 0 radians, it's a 0 radius. So that's just a point right here at the origin. Now, when it's pi over 2 for the angle, it's a radius of 2. So pi over 2, remember, is straight up, and a radius of 2 means you're 2 away from the origin, so that would be a point right there. Now let's just keep plotting points before we draw the curve. So at pi radians, which is to the left, the radius is 4, so we count 4 away from the origin, which would be a point that's here. At 3 pi over 2, that's straight down, the radius is 2, so that would be a point right here. And at 2 pi, it's back to being 0, so that's just the origin again. We already have a point drawn in right there. Now what you have to think of is the movement. So look over at our wave. From 0, 0 up to pi over 2, the radius, I should have probably labeled this, but the y-axis over here corresponds to the radius of the polar graph. And the x-axis, that's the theta. I think that was probably obvious. So now that green portion that I highlighted, the radius is just increasing until we get to 2. So look back at our polar graph, and that means I would have a curve, starting at the origin and getting bigger until it reaches up to 2. And then if you go back to looking at our wave, from pi over 2 to pi, the radius is still increasing up until it reaches 4. So I'm going back to my polar graph, and from the point at pi over 2, I'm reaching out until I get to pi, which is a distance of 4 away from the origin. Now, maybe highlight this in blue. If I look back at my wave, now the radius is getting smaller as you go towards 3 pi over 2. So I'm going to connect from pi to 3 pi over 2, like that. And then from 3 pi over 2 to 2 pi, if you look, it's getting a radius even smaller down to 0. So that means it's going to reach and come in towards 0. And since everything's black, it's kind of hard to see. So I'm going to highlight the path that we just graphed on the polar graph. So watch carefully. We went from here to pi over 2. Then it kept getting bigger and bigger and bigger until it reached out to 4 away from the origin. Then it came back in until it was only 2 away from the origin. And then it finally came back to where it was a radius of 0 at the starting point. This type of shape is called a cardioid. You probably don't have to know that, but it's kind of interesting to know. And now I'll do one more example. Okay, so we're going to try to graph r equals sine of 2 theta. So again, let's list out amplitude. Amplitude is 1. The period now, we always do 2 pi over b, if you remember back a few chapters ago, which would, in this example, be 2 pi over 2. This is the b. So that means that the period is pi. And there's no shifts. I'll just list vertical shift, none. Horizontal shift, none. So if we draw a sketch of the wave, let's do it up here. So here's what the wave would look like. An amplitude of 1 without any vertical shift means it's going to go up to 1 and down to -1. A period of pi means that it'll complete one cycle by the time you get to pi, and let's chop that into 4 parts. So that would make this pi over 2, and then half of that would be pi over 4, and this would be 3 pi over 4. Now the thing is, we still have to show the wave all the way until 2 pi for the polar graph to be complete. So that would just mean we're going to have one more cycle on this picture. So if I label this, it's going to be 5 pi over 4 right here. This one is 3 pi over 2. And this one is 7 pi over 4. And we're graphing sine, which means it starts in the middle, and then it goes up first, back to the middle, then down, middle, and then it just repeats itself. So up to 1, back to 0, down to -1, back to 0. So we have 2 cycles. But when we're doing this technique to graph polar graphs, we need to show always the wave up until 2 pi. That's important. All right, so now let's make some polar paper over here. I can see ahead of time that the largest my wave got was 1, so we actually don't need a whole bunch of rings this time. Let's just draw 1 ring. And then we'll go through and plot all of the major points, which are those ones that I'm highlighting. Okay, so we're going to go through and plot those first. Then we'll figure out the movement. So when theta, let's label our axes again. So remember, the x-axis on the wave was for theta, and the y-axis is for r. Okay, so when theta is 0, r is 0. So that's just a point at the origin. When theta is pi over 4, okay, now imagine pi over 4, goes like right through there. The r is 1, so we're 1 away from the origin. At pi over 2, it's back to being 0. That's just at the origin, so we don't have to replot that. That's already there. Now at 3 pi over 4, which is over here, this point right here is saying that at 3 pi over 4, the r is -1. Well, there's 3 pi over 4, but if the r is negative, then we reflect it 180 degrees over to here. So that's the 3 pi over 4 point. Then at pi, it's back to 0. Then at 5 pi over 4, which is located here I can even label these. If you look at our wave, the radius is 1, so that puts a point here. At 3 pi over 2, it's back to 0. That's just the origin again. At 7 pi over 4, which is over here, I'll draw a little arrow. It's saying that the wave is showing us that the r is -1, so that flips it, it reflects it again, 180, so that puts a point right over there. And I'll label these too. So this was 5 pi over 4, and this is pi over 4. Okay, now it doesn't look like much, but these are the most important points. So now we look at the movement of the wave. I'll do that in green. So starting at 0, 0, until you get to pi over 4, the radius was just getting larger and larger. So what that means is starting at the origin, I can swing up and reach to pi over 4 like that. Then from pi over 4 back down to pi over 2, the radius was getting smaller and smaller. It was still positive, but it was reaching towards 0. So that would indicate that right there. Now here's the tricky part. Maybe I'll do this in blue. Between pi over 2 and the next angle, which is 3 pi over 4, the radius became negative, which means we reflect that. So between pi over 2 and 3 pi over 4, that would normally be in this region right here. But it's going to be reflected 180, so that's actually going to take us over to here on the circle. And the radius is going from 0 to 1. So that means I'm going to go like this and reach up to there. Then, from 3 pi over 4 to pi, the radius is still negative. Now see, 3 pi over 4, oops, I labeled that wrong. Sorry about that. That's 3 pi over 4. From 3 pi over 4 until you get to pi, that's that most recent blue that I just shaded. The radius again is negative, which means it's going to flip it over into the fourth quadrant right there where I just shaded. And it's going from -1 to 0, so it's going back like that. All right, now we are back to the easier part. It's always easier if it's a positive radius. So from pi until 5 pi over 4, the radius is just getting bigger. So I'm starting at the origin, and from pi till 5 pi over 4, it's getting bigger until it reaches till there. And then after that, it's going back to 0. That's this part that I just graphed. And then for one more tricky part, you can probably guess what this is going to look like at this point, but let me highlight this in, let's go back to blue since it's negative. So between 3 pi over 2 and 7 pi over 4. I'm going to get rid of the old shading so you can see more easily. Okay, from 3 pi over 2 to 7 pi over 4, that's in this region right here. But the radius is negative, so that reflects it over to here. So that's where our drawing will be. And it's going from 0 until -1. So it's going to reach up, up, up to there. And then finally, from 7 pi over 4 until 2 pi, which is located, I'm going to do this a different color. 7 pi over 4 until 2 pi is this region, but we still have a negative radius, so that flips it to here. It's going from a -1 radius back down to 0, so that makes it go like that. And we we don't need this shading anymore. So if we look closely, this is our final picture. I'll highlight it in yellow. Here's how we exactly did it too. We went like this and then back to 0. Then, because of negative radius, it went like this next. Then it went, let me think here, it went from pi to pi over 4, so it went like this next and back to the origin. And the final place where it ended was here because it was reflected from the 4th quadrant back to here. And it went like that and back to the origin. So we have what's called a 4-leaved rose. All right, but my recommendation is to always try to draw the wave first. The wave, that's the part with amplitude, period, and all that. Amplitude, period, etc. All the way through 2 pi. Even if the period isn't 2 pi. You want to keep drawing the wave until you reach 2 pi. That's step 1. And then mark the major points onto the polar graph. And then finally, draw the movement of the wave onto the polar graph, and then you'll have your complete curve. So this is the polar graph. And this up here, I wrote it kind of small, but that was the wave. And I hope that helps.